My name is Ron Sledge from King Engine Bearings. I'm here today with Ron Shaver from Shaver Racing Engines. Today we're going to install a crankshaft and show you how it's supposed to be done. We're using the King XP tri-metal bearing today, and tell us a little bit about what you do at Shaver Racing Engines to install bearings.
Well, we're kind of finicky about how we do it, but on the main bearings, is what you're seeing here today. We install them all, and we mic them all over. We mic them straight up and down at 12 and 6, and then we mic them at 10 and 2. And on a sprint car engine like we use, we shoot for somewhere between 2.4 and 2.7. And on the rear main, the crankshaft whips around a lot. We give it a little bit more room. We usually use it about 3 to 3.2. And it's really important that you do that. If you squeeze that down to where you would be equivalent to the other four mains, you're probably going to grab that bearing. One thing I forgot to add is we always make the thrust clearance a little bit roomy, somewhere closer to 10. We use the King bearing for that purpose. It's heavy duty. It works really well.
Ron, we appreciate that. Let's get on with the demonstration.
Okay, let's go.
The first thing we're going to do is to identify matching caps. Generally, caps are marked with a position number. It is very important that caps be matched with their corresponding counterpart to ensure a proper fit after reconditioning. Failure to match caps could result in poor bearing performance or even failure. Before installing the rod bearings, torque the rod fasteners to spec. Check rod housing conditions for size, roundness, and surface finish. Refer to manufacturer specs for the correct housing bore size to ensure the housing ID matches the correct bearing installed OD. Use a good inside micrometer. Move the pins around inside the bore. This will tell us if our housing is round. Bore should not be more than 5/10 out of round. If the housing is out of round, poor bearing performance can be expected and possible bearing failure. If rods have not been reconditioned, check the condition of the bore surfaces for possible defects. Surface finish should be around 40 to 50 RA. Before installing the main bearings, torque the main fasteners to spec and check main housing conditions for size, roundness, and surface finish. If the main line has not been reconditioned, check for main misalignment using a straight bar. Refer to manufacturer spec for the correct housing bore size to ensure the housing ID matches the correct bearings installed. Like the rods, use a good inside micrometer and move the pins around inside the bore. Bores should not be more than 5/10 out of round. Like the rods, if the main housings are out, then the main bore should be line honed. Our block that we're using today has already been through the line honing process, and our bore surface finish measures a good 40 to 50 RA. The next thing we need to check is our crankshaft. Our rod and main journals need to be checked for size, shape, and finish. Using a good calibrated outside micrometer, measure each journal starting with the rods and record the size. Move the micrometer around the journal to check for out of roundness. If your crank is out of round, either replace it or have it reconditioned. All crank journals should not be more than 2/10 out of a round to avoid bearing wear. Check the latest King catalog information for journal sizes and available bearing undersizes. King offers a variety of undersizes in addition to standard. Before doing any assembly of the crank and block, make sure all surfaces are very clean. Use hot soapy water, barrel brushes, and compressed air to remove any debris. It is very important that there be no foreign material present in the engine before starting it, otherwise bearing damage can occur. Unpackage the new bearings and wash them with solvent cleaner to remove the factory applied rust inhibitor oil. Carefully install each rod and main bearing into its appropriate position, making sure oil holes and locating lugs match up. Refer to the King bearing catalog for the correct position of each bearing part number. Firmly push each bearing into its bore. A slight snap should be felt when the bearing is fully seated in its bore. Check for proper oil hole and locating lug alignment. Install all caps and torque all cap fasteners with bearings installed. With an inside micrometer, measure all bearing IDs and record their sizes. Loosen all fasteners and remove all caps from the block and connector rods. At this point, calculate bearing clearances by subtracting crankshaft journal sizes from assembled bearing ID measurements that we had recorded. If clearances are good, then we are ready to install the crankshaft into the block. Apply a sufficient amount of high viscosity pre-lube oil to all the bearing surfaces. Make sure the oil completely covers the bearing surface to include the thrust face surface on the flange thrust bearing. At this point, lube the rear main oil seal. With the engine block in the inverted position on our engine stand, carefully lower the crankshaft into the upper main bearings, taking extra precaution not to damage the thrust bearing. The crank should be in perfect alignment with the block as it is lowered. Spin the crank to spread the pre-lube oil to all surfaces. Carefully place all main caps into their respective main saddles, making sure the caps are in the correct position and oriented in the correct direction. Check the markings on the sides of the caps. Do not get them mismatched. Tap each cap with a mallet to ensure it is properly seated into its saddle. Lubricate and assemble main bearing fasteners to the caps and speed handle them down. Force the crank all the way back to seat the thrust bearing. Using a good calibrated torque wrench, set the correct torque in foot-pounds according to the torque specs from the manufacturer's listings. Next, torque each main cap fastener, starting at one end of the crankshaft and progressing to the other end. After each main cap has been torqued, hand spin the crank to check for possible binding. If any main position binds, you will know which one is causing it. After all the main caps have been installed, we need to check our in-play. In-play on this racing engine should be between 6 and 7 thousandths. On standard duty engines, 4 to 5. Take a pry bar and force the crank all the way to the rear, forcing the crank to hit against the front face of the thrust bearing. Measure the space between the thrust surface of the crank and the thrust surface of the bearing. This can be done two ways. Use a feeler gauge or a dial indicator. We will show both methods. The dial indicator way is the most accurate. We're showing 7 thousandths, so we're good to go. Now we're ready to assemble a connecting rod assembly to our crankshaft. We will start with number 1. First, assemble the piston to the connecting rod small end using its wrist pin. Lubricate all connecting rod journals and cylinder walls with a high viscosity pre-lube oil. After orienting our piston rod assembly for direction, lower the connecting rod assembly into the number 1 cylinder, guiding the rod till it makes contact with the corresponding rod journal. Firmly seat the rod assembly onto the rod journal. Assemble the matching connecting rod cap to the rod. Lubricate and install the rod fasteners and speed handle them down. After setting our torque wrench to the correct torque spec, we will apply the correct amount of torque on the fasteners to adequately crush the bearing in our housing. Spin the crankshaft to make sure our rod does not bind. Repeat this process for all cylinders, spinning the crank after each assembly. Refer to measurements taken earlier to ensure proper oil clearance. Our final step in the process is to prime the engine. By priming the engine's lubricating system, we are ensuring that oil is present in oil galleyways and bearing clearance spaces. By preventing a dry start, we are eliminating the chance of damage to the bearing and journal surfaces. If available, and as we are showing in this demonstration, a spin and pressure test is an excellent way to know that oil has reached critical bearing lubrication points and to determine the actual operating oil pressure. Other acceptable methods are to use a good engine pre-lubricator or just simply rotate the oil pump shaft with an electric drill motor. Oil should freely flow out of the bearings during each method.
Well, that's it for the demonstration on installing the crankshaft here at Shaver Racing Engines. Ron, we're just real appreciative of you allowing us to come in and do this demo using the King XP bearings. And we look forward to continued relationship with Shaver Racing Engines, and if there's anything we can do for you in the future as far as any technical help, we will certainly be glad to help you with that. And so we're, again, just much appreciative, and thank you for allowing us to come in.
Well, we appreciate you helping us out. The guys at King have been really helpful. We've done a lot of testing with this bearing. We've tested the XP. It's an excellent bearing, and they have even better stuff coming down the pike.
I would like to also invite everyone to visit the King website, www.kingbearings.com, for the latest catalog information. Just click on e-catalog, go there and register, create your username and password, and you'll be able to go back in later and check the latest applications from King catalog. We have also printed versions, but the most up-to-date information is, of course, the e-catalog itself. We have a HP brochure that's available at your distributor. talks about the HP and the XP. The XP is, of course, the bearing we installed today. So I would invite you to go to that website, check out all the technical articles that are available, and then also, again, check on that e-catalog for all the King latest application.